Afternoon, all my dear students. Today I brought you in front of all the lecture on liquid fuel and gaseous fuel. In the previous lecture of fuel and combustion, we have read the solid fuel coal. What is the coalification? How we go for the analysis of coal? Now we have to understand the liquid fuel and the gaseous fuel. So we start from the liquid fuel. So one of the important liquid fuel, a natural fuel, is petroleum, which is derived from petra, that meaning rock, and oleum meaning oil. It is a dark greenish brown viscous oil which is composed of many hydrocarbons like paraffins, cycloparaffins, olefins as well as aromatic hydrocarbon. It is also called crude oil. Crude means the raw oil found in the deep earth crust. What is the average composition of this crude petroleum? The carbon is 79.5 to 87.1%. In a higher percentage, we have the carbon, then the hydrogen, which is almost 11.5 to 14.8. That is the highest percentage, that is 14.8 of hydrogen, and the carbon highest percentage which is to be found in petroleum, that is 87.1%. The sulfur is 0.1 to 3.5%. Nitrogen and oxygen also present, which is about 0.1 to 0.5 percentage. What is the significance of this petroleum, or we can say the importance of the petroleum? It is used as a main fuel in IC engine, internal combustion engine, and runs the automobile, ships as well as airships. So that is the first main important use of the petroleum. It is used as a main fuel. Then the second most important importance we have of the petroleum, it is used as a lubricating oil. You have read about lubricants. So lubricants are those substances which reduce the friction between the two moving, rolling or sliding parts. So for reducing the friction in the machine as well as to increase the life efficiency of the machine, the lubricating oil is used, that is the petroleum. Then the third most important significance is products like paints, cold cream, you know about petroleum jelly, that is also a petroleum product which we go for using. In lotion it is used, in ointment it is used, as well as in the shampoo also it is used. It can also be used as a source of asphalt, ya pitch, used for making road construction. It is also used for making road construction. Now we go for understanding the classification of the petroleum. As I have said in the earlier slide, it is composed of various hydrocarbons, paraffinic, olefinic, aromatic. So let's see how we classify the various hydrocarbons in the petroleum to understand. So first is according to its chemical nature. The first category is paraffinic base. It is of number of straight chain or branch chain of the saturated hydrocarbons. And saturated, you know, the molecule which is having single bond. So that are called as a paraffinic base. It can be straight chain, it can be branch chain. For example, that's CH4, that is methane, one carbon atom, to C35H72. All are having single bonds. In the initial level, from the first carbon, methane, ethane, butane, propane, they are liquids. From carbon 18, C18H38, to carbon 35H72, they are semi-solids, which we can understand they are waxes, or which is used for the preparation of candles. So they can be classified as a paraffinic base. So when they go for ignition, it burns with the long sooty flame, a black smoky flame. Sooty means black smoky flame. The second category of the petroleum is naphthenic base. What is naphthenic base? It consists of naphthalene or substituted naphthalene product, along with a little quantity of paraffin as well as aromatic hydrocarbon. It burns with the short non-sooty flame. So that is the second type of the classification of the petroleum, naphthenic base. And the third is mixed base, which is a mixture of paraffin and naphthenic base. So we can classify the petroleum into three main types. The first is paraffinic base, the second is naphthenic base, and the third is mixed base. Now we come to the refining of the petroleum. What the process refining means, the oil or a petroleum which formed from the earth's surface or earth's crust, it goes for having various impurities. To remove the impurities, we should go for the refining process. So the main refining process includes the fractional distillation. So here we can understand the impurities can be removed by the process. It is the process in which petroleum is separated into different fractions having different boiling point. It is called refining of petroleum. The petroleum consists of a number of components or the fractions in it. Then we go for separating those fractions by the process fractional distillation on the basis of different boiling point. So that is the main step of the refining of the petroleum, to separate out the fractions. Along with that, we can go for removing the impurities like sulfur content, which is responsible for the foul smell in the petroleum. That can also be a step of removing the sulfur as an impurity. But here we have to more focused on the separation of fractions. How we go for separation of fractions on the basis of boiling point. So that comes in the important step of refining of petroleum. So let's see, this is the step fractional distillation of the petroleum. The crude oil which is obtained, it is to be heated in an iron retort. It is retort means it's like a furnace at a temperature. When we go for heating or burning in a high temperature, we always use the furnace. So we have to increase the temperature up to 400 degree centigrade, due to the volatile components of the oil gets evaporated and then it is collected in the another flask, cool down and go for its use. So here you are able to see the fractional distillation assembly, where we have taken a crude oil which is heated from a retort, iron retort. It is passed through the iron retort, where it is heated up and passed through the fractionating column. So the crude oil is first passed to the furnace where it gets heated, and then it is passed to the fractionating column. So initially at the low temperature, when we go for heating slight less than 70 degrees centigrade, what happened? The gases evolved from the petroleum. So the gases firstly evolve, which is separated from the upper side of the fractionating column. It vapors are producing, then we cool it, and then we go for using in the cylinder. It is compressed in the cylinder and it is used for heating, which is called LPG, liquefied petroleum gas. So LPG, which is used mainly for the as a domestic gas for the heating, cooking purpose, that is here. So gases first of all separated, cool and used for the heating. Now as the temperature increases up to 70 degrees centigrade, then what happens? The petrol vapors or the gasoline vapors evolve at 70 degrees centigrade. So at 70 degrees centigrade, all the vapors of the petrol or the gasoline is collected and then it is cooled and it is used as a fuel. Then when the temperature more increases up to 120 degrees centigrade, then we have the vapors of kerosene. So kerosene vapors are collected, then cooled and it is used as a fuel. Then we have a 270 degrees centigrade. Up to that temperature increases, we have a lubricating oil separation. So lubricating oil vapors are generated at 270 degrees centigrade, which is collected, then cooled, come to the liquid form and used in the lubrication. When the temperature reaches to 400 degrees centigrade, then we have a fuel oil vapors, which can be again cooled out and in the liquid and used in the application. So when all these fractions are removed, finally at the high temperature 600 degrees centigrade, only a residue left in the fractionating column, which is called asphalt or bitumen, which is a black thick oil which is used for the road construction. So that is only the left behind residue after all the fractions are separated from the petroleum. So that residue is called asphalt, pitch or bitumen, which is used for the road construction. So that's how the fractional distillation or the refining of the petroleum takes place. Now, another important thing to understand after the petroleum liquid fuel and its classification and refining, there is a one important thing in the liquid fuel to understand, that is cracking of oil. What is cracking? Cracking means breaking or decomposing of high molecular weight of boiling fraction, which is having high boiling point. It breaks into the lower molecular weight fractions by giving heat to break the chemical bonds or in the presence of catalyst. So that's the process cracking is. So breaking or decomposing of high molecular weight hydrocarbons having high boiling point into low molecular weight hydrocarbons having low boiling point by giving heat or in the presence of catalyst. Here you see an example of decane C10H22. If such a high molecular weight hydrocarbon it is there, if we break it in the presence of heat or either we can use catalyst. So what happened? It break into two type of low molecular weight hydrocarbon like C5H10, that is pentene, it is olefin, and C5H12, that is pentane with a single bond means paraffinic. Olefin means double bond and paraffinic you understand that is single bond. So high molecular weight decane converts into two lightweight, light molecular weight hydrocarbon. This is the process called cracking of the oil. Why we go for the process? What is the significance of doing cracking in oil? The main thing are the two important reasons. The first is to increase the yield of the petrol or a gasoline because it could not meet the increasing demand. As the demand of the petrol or the gasoline in the automobile, it is goes on increasing, so that whatever the gasoline or petrol we obtain from the fractional distillation of the petroleum, it is not sufficient to meet the demand, so that to enhance the yield of petrol or a gasoline, we should go the process cracking. That's the main thing, main reason. The second reason is we can increase the quality of the petrol or the gasoline by using this process or by the cracking process. So these are the two important significance of doing the cracking of the oil or of the petroleum, or we can say the fractions we obtain. So as in the definition it was clear that cracking can be done by heating or in the presence of the catalyst. So we can classify the two type of cracking. The first is thermal cracking and the second one is catalytic cracking. Thermal cracking, which is carried out under high temperature as well as high pressure, and catalytic cracking, it is carried out in the presence of catalyst at the high temperature and low, moderate or no applied pressure. So these are the two important type of cracking process. So either we can perform thermal cracking or catalytic cracking. Thermal cracking, which is required under high temperature and high pressure, can further be divided into two types. The one is liquid phase thermal cracking. The another one is vapor phase thermal cracking. So what is liquid phase thermal cracking? As the name is telling us the idea about liquid phase. Liquid phase is at the low temperature and the vapor phase is always at the high temperature. So we can understand when the cracking takes place at low temperature and high pressure, that cracking is called liquid phase thermal cracking, and vapor phase thermal cracking which takes place under high temperature and low pressure. So here I have which type of temperature and pressure is required in liquid phase. Here you can able to see low temperature, that is 475 to 530 degrees centigrade. We can use for liquid phase thermal cracking, and high pressure 100 kg per centimeter square we can go for liquid phase thermal cracking. In vapor phase thermal cracking, temperature is high, that is 600 to 650 degrees centigrade, and the pressure is low as compared to liquid phase, as you are able to see 10 to 20 kg per centimeter square is used in vapor phase thermal cracking, and in liquid phase we have used 100 kg per centimeter square pressure. So this can be done. We can go for thermal cracking in two types, liquid phase thermal cracking or vapor phase thermal cracking. But what the difference we found in the liquid phase thermal cracking, the octane number of the petrol or the gasoline found 65 to 70, and in vapor phase thermal cracking the octane number found greater than 70. What's the octane number telling us? The octane number decides the quality of the petrol or the gasoline. Higher the octane number, better the quality of petrol. So you can see where the octane number is higher and octane number higher value where we are getting in vapor phase thermal cracking, that is above 70, while in liquid phase we are getting 65 to 70 octane number. So we can say quality wise vapor phase thermal cracking is more better than the liquid phase thermal cracking. because its octane number is greater than 70 in vapor phase. That's why vapor phase is more better thermal cracking than liquid phase thermal cracking. And in liquid phase thermal cracking, as the temperature is low, so more time is required. While in vapor phase where the temperature is high, less time is required. So this is also the difference we obtain. And the fourth difference, you are able to see less anti-knocking properties in liquid phase thermal cracking and better anti-knocking properties found in vapor phase thermal cracking. Again, it's a quality criteria, anti-knocking properties which reduces the knocking problem. Knocking is a problem found in the petrol or the gasoline. So how much knocking can be reduced? That is the anti-knocking property, which is found less in liquid phase, but it is very high in vapor phase. So we can say all over the thermal cracking, vapor phase thermal cracking is more advantageous than liquid phase thermal cracking. Now the second cracking is catalytic cracking in the presence of the catalyst. So there are various advantages of catalytic cracking over thermal cracking. We can use the catalyst, and you all know the catalyst enhances the rate of reaction. Here the catalyst we can use for the cracking, that is aluminum silicates or synthetic hydrated aluminosilicate. So in the presence of the catalyst, the time also reduces in breaking. So less time is required when we go for using a catalyst, as well as lower temperature and pressure is also required. We have to go for the thermal cracking. We have to give either the high temperature or either the high pressure. So temperature and pressure should be increases. In the case of catalytic cracking, when we go for using a catalyst, the temperature and pressure requirement become less. And you are able to see how much temperature is required in catalytic cracking, that is 425 to 450 degrees centigrade, and very less pressure, 1.5 kg per centimeter square in the catalytic cracking. The quality as well as the quantity, both of the petrol and gasoline is increased. Quality also enhanced and yield, that is quantity, is also increased in the catalytic cracking. So catalytic cracking has these several advantages over thermal cracking. In the thermal cracking, vapor phase thermal cracking is more better. And as we compare thermal and catalytic, the catalytic is more better than the thermal cracking. Next, we move to the gaseous fuel. Gaseous fuels we have studied in the classification on the basis of the state of the aggregation of the molecule. It can be primary, it can be secondary. The one of the important primary gaseous fuel, it is a natural gas which is usually found near the petroleum fields under the earth's surface, which is mainly consist of methane gas. The higher proportion is of methane gas and the small quantity of ethane, propane and other hydrocarbons. It is found under the earth's surface. Its calorific value is 30 megajoule per meter cube. It is used for the domestic and industrial heating. So natural gas is the primary gaseous fuel. Now we move toward the secondary gaseous fuel, which is prepared from primary natural gas. The first is coal gas, which is also called town gas. It mainly consists of hydrogen, carbon monoxide and the hydrocarbon. It is prepared by carbonization of the coal. During the carbonization is the process of forming the coke from the coal. So during this process, coal gas is formed. So which is also called town gas. It is used in the towns for the street and domestic lighting as well as cooking. So that is the coal gas. The next synthetic or secondary gaseous fuel is producer gas, which is a mixture of carbon monoxide, hydrogen, methane, nitrogen, water. It is obtained from the partial combustion of coal, coke, or peat when they are burnt with an insufficient quantity of air. We can say incomplete combustion. We also say what's the reaction meaning, incomplete combustion reaction, where the sufficient quantity of oxygen is not provided to the fuel. It is used in the steel industries for firing as well as open hearth furnaces. The third gaseous fuel is water gas. It is produced by blowing the steam into the white hot coke or coal. It is a mixture of hydrogen and carbon monoxide. It burns with a blue flame and it is also called blue water gas. Usually mixed with the coal gas as a town gas. It is used in the furnaces as well as a welding gas. So that is the another synthetic gaseous fuel, secondary gaseous fuel, water gas. The next synthetic gaseous fuel is blast furnace gas. It is obtained from the metallurgical furnace called blast furnace, which is used in the extraction of the metal from its ore. It has a very low heating value, about 93 British thermal unit per cubic foot, because it consists of 60% nitrogen and 18 to 20% carbon dioxide, which are not flammable. The rest is carbon monoxide and hydrogen. It is commonly used as a fuel within the steel works, but it can be used in boilers and the power plants. The next is liquefied petroleum gas, which is commonly known as propane, a combustible hydrocarbon based fuel. It comes from the refining of the crude oil and the natural gas. It contains 85% of propane and butane. Good cold start and warm up characteristics due to its gaseous state. It is having high anti-knock quality of LPG, which provide an opportunity for the use in engine performance. To contain low sulfur content. It is used in industrial and the domestic heating purpose. The next fuel is a biogas, which is a mixture of methane and carbon dioxide. It is obtained by anaerobic digestion. It is used for any of the heating purpose such as cooking in the gas engine to convert the energy directly into electricity and heat. It's a renewable energy source that can be used for heating as well as electricity preparation and many other operations, which can have an alternative fuel of all the synthetic fuel, which creates problem in the environment. So that is the biogas. Thank you and take care.